So yeah, it's fairly straightforward, but really it's about getting the data for the workplace charging. And it's a good data set.
The conference has been muted.
You can find, it enables any part of the state to be analyzed. Okay, so the fast charging tool. Now this is a very ambitious effort, and I have to say Wei has been fantastic in programming this and making all these interactions kind of come to life. With the fast charging tool, we rely on, that says 2009, it means, I should say 2012, Caltrans survey of over 42,000 households. And so people actually filled out a survey, 42,000 people filled out a survey that said, I started at home at this time, and I went to this place. Then I went to this place at this time, and this place at this time. So we know dwell time, we know distance. And the reason this is important that it's a Caltrans survey is because Caltrans data has very long trips, which if you take regional data, you probably won't be able to gather or get a lot of the long trips, and the need for fast charging actually comes from outside of your region. So if you start doing planning, you may end up with fewer fast charger or lower predicted demand than you will actually end up with from people outside of your region. So making that analysis frame a little bigger is why we use the Caltrans study. So we look at, it's 1 day of travel. There are limitations with this data set. Here it says we use only non-work trips, but actually you can include the work trips to see on work trips what might the applicability be of fast charging. We don't necessarily think on routine trips that it's going to be as applicable as non-work trips. So we separate out those two kinds of trips. And the functions evaluate current chargers. So let's say we have chargers in the ground right now, and we want to say, well, how many people do we expect to use those chargers? You can evaluate proposed locations. So you have the current chargers in the ground, and you propose locations in the context of those current chargers. So how much will this charger handle, and how much will this new one take away from another one? Or if there's no demand, it'll take all the demand. I mean, if there's no other charger to take the demand, this new charger could take all the demand. And it can also choose new sites that are underserved. So you can put in, not necessarily, you can put in maybe current chargers, you can put in proposed chargers, but then you put in a bunch of other just imaginary chargers and to see, well, what might be the demand in other places. So it's based on something we call a charge window. And if you look at the bottom right, from D1 to D4, you see there's a trip, and it's an 85-mile tour. And anywhere along the red line, you could charge and complete your trip. So you have to go a certain number of miles to create space in the battery to be able to, if you charged up in Lodi, for example, you could make it all the way to D4 in Livermore. You could also go all the way to Tracy and charge there. So there's a big corridor. It's not one place. It's a whole corridor that you could charge at. And so the top example where we have chargers N and M, you can look at how many charge windows intersect those different chargers, and you can evaluate based on the weights of those lines how many people actually do that trip. For example, B1 to B4, we weight these trips based on how many people live at B1 and own appropriate vehicles at B1, and then that trip has a certain weight. The B1 actually we do on a county basis because there are so few trips. 42,000 sounds like a lot of trips, but it's not really a lot of trips. And so we look at anyone who starts in that county is likely to take a trip to San Francisco. How many people from I guess that's Placer County go to San Francisco, or I guess Napa in this case. And so we do, the projections have to be how many BEVs are in of a certain size are in a certain county, and then we weight the trips that way. But you can evaluate based on those weights which charger is going to be better, or if they're existing chargers, how many people would intersect those chargers given current distribution of vehicles, or some future distribution with current chargers. So you can change the distribution of vehicles, and you can change the distribution of chargers, and you can look at current chargers, proposed chargers, and then just future chargers. So I'm not going to go through this, but yeah, this is just, we scale demand by all these things. I'm not going to make you read it, but there are different ways to figure out how many people each line represents. So the other thing we do to scale demand is kind of, as I alluded to earlier, I showed this graph that if you have to charge twice, half as many people are going to do that. So the demand is cut in half for that trip. So let's say we say 100 people are going to intersect this place, and it's going to take 2 fast charges. You'll say only 50 people are going to show up. If it's 3 fast chargers, only 13% of those 100, only 13 people would show up. So we scale the demand that way based on the survey evidence that we described earlier. So I'm not going to go through that just in the interest of time, but these are some of the scenarios we wrote. I kind of described earlier, so we have current distributions and the current fast charger network, current distribution, and a proposed network. Or we can have a future distribution where we have lots of BEV 150s and 300s under the current chargers, and then what's left for future chargers. And then you can put in different things. So these are different things we ran. This is an example of current battery electric vehicles, excluding Tesla, because at this time, or for this scenario, Teslas were not compatible with the existing fast chargers. Now they are. You can probably put them in. But they have their own free network, so there's some issues there. But given existing DC fast chargers, what is the demand that you might expect, and what's missing on these kind of medium or short trips based on the battery size? And you can see that here you see in the red, that's the existing DC fast chargers, and there's some proposed ones we looked at in this scenario. How many people might show up at that in the context of these other vehicles? And then what are these areas that show that there are a lot of people that make these trips, and there might be apparent demand that is not served by existing fast chargers? And you see up here, going to Vallejo, there's a going over to Tracy here, and then down from San Jose, Gilroy, and Santa Cruz. And if you're familiar with the area, those places would make sense. But these are potential areas where BEV 60s and 80s would want to travel given the current distribution of travel and the limitations on how far they would want to go. So you can look at that. And again, this is my modeler slide that says, you have to be careful as a modeler to interpret the demands appropriately. It was mentioned earlier about pricing. So we do see situations in which there's a free charger next to a paid charger, and lo and behold, more people want to go to the free charger. Some people may actually make more effort to go to the free charger, and some of these estimates of how many times people want to stop maybe is skewed one way or the other, and you're going to get different demand based on the price difference of a fairly similar location charger. So this has happened a couple places. Vacaville is one example where there's a free next to a paid charger. Congestion uncertainty. So this is assuming people the answers that we got are given under the assumption that they're uncongested charger and you can depend on them. You might end up with lower results or lower real results if the chargers are congested. People may not make these trips if it's unreliable. There's hours of operation. We're assuming 24 hours, only county level data. So there's all sorts of things. This gives you a general idea, though, of where demand could exist, and caveat the heck out of it. So evaluating future demands. In this, for example, battery electric vehicles are going to get bigger. There's going to be BEV 200s, for example. In this one, we didn't do BEV 200s, we did BEV 150. You might actually think that's kind of what is represented by a BEV 200 anyway. Under rain and strong winds, your BEV 200 may actually be 150. So And in this scenario, it's 50% BV80s like a Leaf and 25% BEV 150s and 25% BEV 300s. So what would happen under that scenario? So we see that scenario I showed in the beginning was kind of the present scenario where people, they don't necessarily go on these long trips and they use the BEVs only for short distance trips. And we see that the demand is fairly restricted to places that are near where people live. And you see, for example, I-5 is a kind of a classic example of where you wouldn't necessarily expect demand from today's vehicles based on what people say. You might expect a little more demand on California 99 for those short hops, 1 and 2 fast charge tours. But as you go into the future and you have bigger, larger batteries, you might expect some demand to show up on I-5 and 99 in basically a lot of different places, because people won't be taking other cars; they'll be taking their BEVs on some of these longer distance trips. So again, this is percentage of demand, not magnitude, to show kind of the difference in the distribution. So some initial results, and I wish I had highlighted these, but I think this non-work purpose is the one that I would focus on. And you see BB range of 80, 150, 300. The interesting thing is that the total consumption in kilowatt hours, I think, goes down by the average consumption per kilowatt hours per car per day goes from 0.33 kilowatt hours per car per day to 0.11. So as the battery gets bigger, fast charging is demanded less. It's by 1/3 in terms of kilowatt hours. However, if you look at the number of charge events, it goes down by 10 times. So basically you get these monster charges with larger battery vehicles, and the events go down, but the kilowatt hours goes down, but not by quite as much. So those are some things you can get out of the model and scenarios you can run. Again, I'm not going to go too much on. I'm going to skip this, but just the point of this is that if you use a regional model, you're not going to get demand from outside of the region, and you could be off by as much as 70% in a smaller region. So Sacramento is a smaller region. You can be off by 70 to 90% of your demand is going to come from outside the region, depending on the size battery car you're looking at and the size of the region. If you have a larger region like Los Angeles, you'll capture more of the BV80 demands, but as you get bigger batteries, you'll miss your projections. And so it's good to use a statewide model. Okay, so I'll let Wei go over some of the how to run the model, and this is.
Should we pause?
Oh yes, I guess yeah, pause.
The conference has been unmuted.
Are there any questions on the phone? Any questions in the room?
The conference has been muted.
Okay.
Okay, so for the fast charging model, the idea is saying so it has a bunch of input data. So I think we'll provide data, right? But it will be anonymized, so it's not exactly the same origin and destination, but it will not significantly influence the results. So, like here we use the 148 existing fast charger in California, and the county boundary is county-based, and then this is like we spend a lot of time to create these road lines. So each line here, it's just so you can see there's a lot of green lines, and each line is represent a tree. So it has, if you open the attribute table, you can see that each row is a tree, and it has information like which household it belongs to be, which tourist belongs to be, and the start time and end time of that trip. And this time is in Excel time, so if you times 24, it will be the real times. And the activity duration, and if this trip is for work purpose, and the total tour distance, and the weight of this household, which we calculate based on the formula that has been shown before. And there's some other data that, like, you can set how many BEVs are there in each county, in each battery size. So like you can see that in I think it's Alameda County. It has 14 BEVs with 60 miles range, and it has almost 2,000 BEV80s. And if you says, I know there's more information like they have 10 BEV 150, something like that. But if you say so, then you need to define each county how many BEV 150 are there. So I just make some number. But again, if you have the data, you can change this table, and that will get some new results just to determine how many BEVs are there in each county. And if you don't know the county ID, here is a table that you can look at. And here you need to define how many total households in each county. So this number will use to determine the scale for, the weight for each sample household. And this the scale of each household. This one is I just used from the Caltrans data. But if you have some other data, you can update it. And also, this one is the willingness that people would stop, that people would drive a BEVs when the tour requires no BEV fast charging, or requires one fast charging, or requires even more. And here is the willingness that they will use BEV. Like here, if just requires one fast charging, then all of them will use BEV. But if it requires twice fast charging, then only 49.12 people will use BEV for that tour. So that is all those input that is the model will be used. And then comes to the tour. So it has 4 steps. The first step is pre-processing. You just put the raw line that we generated. So if you are interested in some specific region, then you can just select those regions, the tours that come across those regions. So like right now, this one, it has 70,000 trips that come across SCAC region. But if you want to see the whole California, then for the whole California, it has 190,000 trips. So yeah, so if you want to run a regional model, you just need to choose the tours that you are interested in, and then you define the output location, like create a database and name the routes. Like first is road point. Basically, so the purpose of this step is that he will split the tour, the line into points by every quarter miles. So it will have to do some later calculations. And then the most important step is here. So it will it will analyze the spatial distribution of fast charging demand. So like here you have the workplace, you have the route line same as the previous step, and you have the points that has been generated by the first step. And if you want to, like, say you want to examine the utility, potential utility of existing fast charger stations, and you input all those scaling factors that I just showed you before. And because people will not charge when the state of charge is below like 10%, because at that time the vehicle might not work functionally. So you can say that they will start to charge before the SOC is dropped to 20%, and they will stop to charge when the SOC is getting to 80%. And also you can consider the influence of level 2, the public level 2 or the workplace charging. You can see what's the influence of those level 2 chargers to the fast charging usage. So you can say that the level 2 chargers power is 6.6 kilowatt hours, and you can define some polygons so that the polygon will represent the spatial distribution of level 2. But it is optional, so you don't need to do that. And you can see that I just interested in non-work tours, or I want to consider work tours. And if you consider work tour, will you charge at workplace, and the price at workplace, is it higher than home, or is it same at home? And if in each workplace, what is the threshold that you would charge, you would consider to charge at workplace? Because if it's a too short work tour, then you don't need to even charge at workplace. But normally, especially for fast charging, if you say that the work tour will use fast charging, then it means that it will, because work tour is usually routine tour. So if the work tour use fast charging, then they might need to use that like every day or every 2 days. So I would just say that we will not include the work tour in the analysis. And then if it's not work tour, will they stop at level 2, and when will they stop at the destination to use level 2? We can say that they will charge a non-work tour if they stop at the destination longer than 3 hours, or 2 to 3 hours, or 1 to 2 hours. And then what is the vehicle efficiency, so the miles per kilowatt hour, and the search radius for each fast charging location. So we can say that, so the idea is that we have those points, each point represents one charger, and we create a circle around the points, and the radius of that is 1, and then this circle will represent the service area of that location. If the trip come across that circle, then they can use this point to use, means they can charge at that place. And because it can be a regional model, so you need to tell us how many people are there in each county. After all those settings, then the model is good to run. And there are also 2 more steps. So this is optional, so you don't need to run that. But if you're interested to aggregate the fast charging demand to polygon to county level, then you can do that. So you just input the fast charging charge window that is generated from the previous step, and then let's say you want to know what is the fast charging demand at each county. Then you input the county and the polygon that each the shapefile of county boundaries. So it will aggregate the fast charging demand to each county. And then if you want to predict because there's based on the existing chargers, there will be some fast charging demand that cannot be served. So we call that unserved charge window. And you can use that to say that I have some idea to put some new chargers, and I have their location. So that is a potential charger location. And I want to say how well they will perform based on the unserved charge window. So the calculation is exactly the same as the previous one to calculate the fast charging demand. But yeah, that's just more function. So here we have the results. Like this is a raster. So I run this for SCAC region. So here you can see that where is the spatial distribution of fast charging demand, and this is the existing charger locations. So here we can see that the size of that each dot will be the expected charge events at that location every day. So like right now, I just have this scenario has 160 BEVs in the whole California state, and then the highest charger station will expect to have 5.7 charge events every day.
So wait, how many BEVs?
160,000.
160,000?
Yeah, in the whole California state.
And that's, so that's one region right now.
Yeah, so yeah, no, the 160 for whole California.
Yeah, so in this region,
yeah, this
there's
in,
less than 160.
Yeah, there's, much more.
20,000 in this region. Yeah.
And there's also like the table of charging events, the temporal distribution of charging events. So every day of week, every hour, how many of them will charge, how many electricity were consumed, and also the electricity consumption. Like here, I run a model that will consider work tour and consider level 2, and how many of them will consider I will use for workplace charging or level 2 or fast charging. And yeah, there in the tutorial we write tutorial for each tours, and in the tutorial explain the what each result file means.
Are you sharing this?
Yeah, I'm showing this on screen. Yeah, so it has in the tutorial it will show you step by step how to run this model, like create new connections, setting options, inputs, and explain the results of each output results, what it means, and how you can use that. And we have, if you want to make some visualization, how to make that, to create maps. Yeah, so everything is in the tutorial, and we have a demonstration sample for, this one is for San Francisco region, and yeah, and some explanation of the charge window idea. So everything is in the tutorial, and you can read it. And it also has like the requirements of the data. So what kind of fields, what kind of columns it has, it requires, and the name of each columns, and what it means. Everything is in the tutorial, and hopefully it can explain some questions. And more questions?
The conference has been unmuted.
So questions on the phone? Stunned silence, yeah.
Well, we've bombed them for 2.5 hours by now.
Hey, this is Marco. I keep trying to get my phone off mute and accidentally going away from the screen. So this is Marco in the SCAG region, and you know, this is a phenomenal tool. I'm just trying to think about. I mean, one of our challenges right now, we're right in the midst, I'd say, the depths of preparing our 4-year regional transportation plan, and so there's a lot of interest in these kind of tools, but there's also a huge amount of drain on all of our resources. So I'm trying to think of the avenues that we could use to use this as part of our EV analysis, and so. You guys have covered kind of 3 main modules. How do you see the MPOs and counties and large cities kind of using this tool to derive results? And then, what are, there's a lot of caveats too on the model. So how do you guys see the public agencies using this to identify the key locations and demand?
That's a really good question. And we hope actually people will use it. We think that there's questions that we don't exactly know are going to be answered, or going to be asked. And we hope the tool can be flexible enough to kind of deal with those eventualities. I guess I would say that there's different levels of aggregation, and you can get a much better sense of general trends. For example, the fast charging tool, you may not know the exact sites where it's going to be, but you may be able to get a better sense of important corridors and what's the interplay between larger battery sizes and smaller battery sizes, and so it can help you bound some scenarios. Is this important for BEV 200s? Like which could help you decide maybe where to put faster speed chargers, for example. And so as far as how you use it, I think that's I would hopefully say up to you. I don't know. Gil, what do you?
I think that the way we hope that it will be used is starting with only the default assumptions that we preloaded it, so you don't need to even dive too deep into the data. Just run it with the preloaded data and see if it kind of makes sense. Just change the number of cars into the future and zoom into the region and see if it makes sense. And then we see it as a scenario tool, so you can say, oh, okay, let's see if everyone will drive a Tesla-like car or something like that. Is the location we decided on still makes sense? So we hope that it will be useful even with minimal work on it, and then only if you need or have the capacity, you can start and tweak with it forever, I believe.
Yeah.
So we are trying to make it a minimum effort to start using it.
And I mean, the whole theory behind the tools was that there's so many people who have so many questions, and traditionally we've looked at certain scenarios, and people come to us like, what about this? What about this? And then if people want to, they can start looking at these vast number of scenarios, because we can't necessarily even focus on any region, every region equally. And so we're going to actually use some of the tools ourselves. So we're going to probably be, I suppose, available for analysis. If somebody wanted us to run the tools, we could do that. But we hope it's going to be much more than that, where people can use it themselves. And we do realize that not everyone's a GIS expert. But in MPOs in particular, we think there's a lot of capability, so we hope it'll be used.
Now, the other thing I was wondering is if we had sort of done some sketching out of some methodologies to figure out what a regionally specific growth projection would be for EVs. But then I heard that that ARB is going to be including a growth projection in the MFAC numbers.
Okay.
And it's quite aggressive, so I think they're bending reality to meet the governor's dictates. And I wondered if the market projection tool that you guys have is much more about sort of a spatial analysis of where in a particular region or analysis area things are going to be happening, and less on like a statewide number. But is that does that affect the kind of utility of this tool in terms of the market projections?
We are very we avoid the question of what will be the total number, or if it's a political decision or a market forecast. So kind of on purpose, we are not getting into the discussion of what are the total numbers. And that also allows you as an MPO to put any number you like, the ARB numbers or the MPO best guess or any number you like. We leave it open.
Yeah, and I think it actually goes hand in hand because that's the one thing we don't do, and that's the one thing AMFAC does, but doesn't really give you the spatial distribution and what does that mean in terms of connecting home to work and all that. So it's almost kind of a companion to those larger macro models.
Online question. Is the tool California only, or can it be applied nationally, and in particular for the fast charger portion?
That's a good question. So the fast charger portion is the one that's the most difficult. It can be if there were a data set that showed the distribution of long-distance trips. That's the main thing that drives the fast charger tool is long-distance trips. And we have looked into estimating those in other ways, like stochastically, but so far we haven't done that because, well, it was California Energy Commission, and this is a California tool, so no one has asked us to look at that. So the workplace charging, again, we would have to go into the data and do a little bit more updates because, again, we've scaled this to the survey results we've gotten in California, and so that, like I said, we built it from the ground up, and so we'd have to do a little more investigation on the behaviors in other places to make it work, to get the defaults right. But if you had the data that was similar to the Caltrans data, some sort of either a projection or a survey like California has, then you could definitely use it there, but it's not preloaded for sure.
Yeah, and as Mike said, if you have the data, and I will just add if you have the money. For example, there are good data sets for long trip today based on cell phone data that we can purchase and implement it into the tool. So if there is the interest and the funding, we can adjust it, but right now it's not preloaded with the data.
Yeah, there are data out there. But if you were in a place and you wanted to, try to make the data look like California data, you could use it elsewhere.
I have a question, Microwave. So as far as the fast charging tool, when you have the existing fast chargers, what source are you using? Are you using the US DOE site for the existing ones, or what's your?
We use existing one. We just download from the US DOE.
Okay. And then the second question, NRG sites that are coming online in the future.
Oh, the question is what's the source for the proposed fast charging location that we use, and we think we use.
It was actually a CEC proposed.
Oh, ours. Okay.
Yeah, I mean.
Don't forget NRG too.
It was proposed as of like 4 months ago, and that could have changed. And the point is not to get necessarily the exact scenario, but to be able to show how do you incorporate it into it.
Now my next question is how current is those proposals?
Oh, and that's another thing. It's more about the tool, not about exactly what it is. So yeah, that you can put in. I think there's definitely probably 20 or 30 more than exist in this little scenario.
Yeah, the reason I brought that up is like you had that one point where you showed on the little spots in the Bay Area that were kind of missing some fast chargers. And, we just had Alternative Energy Consulting Services do a survey, and some of their corridors were actually very closely matched up.
Okay.
I just wanted to make sure how that worked out. It's like, well, that's pretty good. Some consistency between two different sources you guys have known.
The same source.
Okay. Did they ask us?
They ask us.
Oh, that makes sense. How much of a coincidence is that?
It's not two different sources.
Okay.
We presented this kind of in different places, and the fast charger tool is going to be a forthcoming paper in TRB if you're interested more in the A scenario, which all three of us are on. So it could be also that too.
And I was just curious because it's very important as we're working on the current solicitation that's going to be coming out this summer. So that was one of our questions. Now, what corridors are the priorities? And that's why.
And this is a little gap that we have with the CEC right now that Pedal and develop the tool, but there is no mechanism of the CEC using the tool over time, except from our, just goodwill of keep maintaining it over time. But there is no real mechanism of CEC using the tool.
Okay. Yeah.
And we hope it's easy enough where anyone at CEC can pick it up and use it. So, or if you wanted to, look at a study, then we could certainly do that.
Yeah, great. Well, thanks for clarifying that. I was just saying, wow, that's too much of a coincidence there.
Okay. Any more questions on the phone?